Start.
So hi everyone, my name is Pooja and I'm presenting on behalf of our Affordable Smart Housing Project team. So our project focuses on 2020 affordable energy efficient step code for modular homes in the Surrey Innovation District. So in the next few minutes, I'll briefly walk you through our overall plan, the key outcomes for the city of Surrey and how our schedule is structured to achieve delivery by September 2026. So this slide gives a high level of summary of our proposal. We are using off-site modular fabrications combined with on-site works and assembly. So work happens in parallel. This allows us to complete all 20 homes in 9 months from January to September. Our risk-adjusted project budget is $8.13 million, which stays with the original 8.2 million estimated and with the sponsors plus minus 5% tolerance. Overall, the plan meets three main goals: affordability, step code for energy performance, and full smart home functionality for resident. Now I'd like to hand over to my friend Vikas for the next slide.
Hello, I am Vikas and I will talk about schedule structure of our project. In the case of schedule structure, we divide the whole project into 16 clear activities beginning with initiation up to handover. These activities are scheduled over 9-month time between January 2026 to September 2026. The use of concurrency is major characteristics of our schedule. Our on-site team is making preparation at the same time. The factory is making the modular units of site, including foundation, utilities, and layout. Through such structuring of the schedule, we will make sure the two teams are progressing in cycle. The materials can be delivered just when the site is ready. Next slide. So this slide shows the key dependency of our project and basically sets the direction for how the whole workflows move. In modular housing, timing and sequence are very important. That's why we organize every task based on what needs to be happen first. For example, the design phase has to be complete before we can start procurement and fabrication. Then fabrication must be finished before we move into transportation and assembly. All these tasks together create our critical path. So if one major issue is delayed, the whole project outline moves. By understanding this dependency, we make sure each steps happen in right order. Now Praveen will talk about next slide.
Thank you, Vikas. It's me, Praveen, and I'm going to talk about our timeline, the most likely timeline. So in January to February, we do design and promise, and in March to June, the factory will build the modules, and then after in April and July, the site will prepare the land and foundation for the project, and also and in July and August we'll bring the module to site and assemble them, and in final 2 months we'll finish inside and test the systems and hand over the homes to the public. Next slide, please. We have two teams here, one in the factory and one in the construction site, and we also have a small management team, a project manager, site supervisor, safety and planners. At the busiest time, we will have around 25 to 30 workers in total. So next slide, please. In phase 1, January to February, we will use a small team about 4 to 6 for planning. And in phase 2, March to June, we will have about 15 to 20 people in the factory and on site. So in last phase, July to September, we will have about 20 to 25 people to assemble and finish the home. Now I'm going to pass my mic to Mohammed.
So for equipment allocation, we aligned our choices with the charter requirement and the key risks from assignment 2. We use excavator and concrete trucks for site preparation and foundation, which are critically early tasks in the schedule. We use cranes, which require to lift and place modular unit, directly addressing the high risk area of installation delays or misalignment. And finally, LOT and electrical testing equipment ensure proper commissioning of the smart system, supporting our step 4 smart home goals. Next slide, please. So our total project budget is 8.13 million. This is slightly below the original charter estimate of about $8.2 million. So we are still within our cost KPI. The biggest share is fabrication at 3.1 million for producing 20 modular units in the factory. Smart system are 1.03 million, which includes solar and IoT technology to achieve step 4 and support long-term affordability. Our contingency and small risk reserves are taken directly from the risk management plan based on high priority risks we identified in risk management plan. Next slide. So this slide explains why those costs look like the way they do. Some phases are labor intensive like site work and interior finishing, so costs rise when we have larger crew on the site. Other phases are equipment heavy such as excavation and craning the modules into places where spending is driven by specialized machinery. Finally, high precision and smart system integration requires skilled trade and careful testing, which increase upfront cost but reduce operational cost later. This spending pattern reflects our risk analysis from risk management plan. We invest more in the tasks we get with higher RBN scores to protect the schedule and avoid costly rework. Now I'd like to pass to Sisir.
Thank you, Mr. Sponsor. My name is Sisir Acharya, and I'd like to walk you through the key risk we are actively managing on your project and how we are keeping delivery stable and predictable. The highest impact risk occur during offsite fabrication. The phase drives the entire critical path, so any turnover or slowdown can affect everything that follows. To protect your schedule, we have built stable fabrication crew and added cross training and secure subcontractors so that production continues without interruptions. Next slide, please. The next major risk is IoT and smart system integration. Because of home will include solar PV, HVAC sensor, and IoT dashboards, and any integration issue could delay step code for certification. To prevent that, we have pre-wired the modules in the factory and assigned certified technician for the on-site commissioning. We are also managing supply chain volatility by ordering critical material early and working with multiple vendors. Permit-related risks are minimized through early and ongoing communication with the city of Surrey, and weather risk during transportation and crane work are covered through built-in schedule buffers. Finally, we have allocated a structural contingency of about $574,000 to protect your budget. Overall, Mr. Sponsor, this control ensure your project stay on schedule, on budget, and fully compliant. Thank you. My friend Umesh will lead from here.
Thank you, Shishir. Now, in this slide, I would like to point out the way we make the small features of every modular house come to life. In this stage, we deploy our certified electricians, solar technicians, and IoT experts to install the relevant technology like the solar PV panel, the IoT dashboards, automated HVAC controls, and the entire energy monitoring system. Next slide, please. This slide addresses our quality and commissioning procedures, which is the final assurances process before any unit is delivered. Here, our QA team, like quality assurance team and energy auditors, review all the details of the structure work, electrical systems, the performance of the HVAC, the functionality of the solar systems, and all the IoT sensors. We conduct step-for-code energy testing and ensure that all the smart features work accordingly in the real world. Thank you. Now, I would like to pass the mic to the Zubaid. Thank you.
Hello everyone, my name is Zubaid and I'm excited to present the part of this project that truly keeps everything running and smoothly, our WBS and KPIs. So think of WBS as the engine of this entire project. It breaks our 9 months mission into 7 clear strategic categories, from design and permits to fabrication, assembly, and smart systems, and final handover. This structure doesn't just organize the work, it drives the work and tells every team exactly what needs to be completed and how it connects the next step and what success looks like at each stage. What makes this WBS powerful is how perfectly it syncs with the schedule and our 8 million budget. Every critical activity, offsite fabrication, crane assembly, solar installation, Internet of Things integration has clearly defined deliverables and timing that means no surprises, no confusion, and no delays on the critical path. So it's efficient, it's organized, and it's built for speed. So and to make sure we stay sharp throughout the project, we have created a strong set of KPIs. These are our performance checkpoints. We track schedule accuracy, budget control, labor productivity during peak phases, and the success rate of our smart system commissioning. We even track step code 4 and energy performance, making sure our homes meet the city's high sustainability standards. Next slide, please. And put all of these together, the WBS and KPIs And we get a project that is transparent, measurable, and fully under control. It gives us the confidence to say, yes, we can deliver 20 smart, energy-efficient homes on time, on budget, and with outstanding quality. Thank you very much for your attention.